Hello everyone, my name is Divyam Singh and I am a student of Bennett University. Today in this video I will be discussing Kruskal's algorithm. Let's start. So the topics that will be covered in this videos is spanning trees, minimum spanning trees, Kruskal's algorithm and its working. Then we'll discuss an example, we'll discuss time complexity and the applications of minimum spanning tree and Kruskal's algorithm. So let's start with spanning trees. What is spanning tree? So a spanning tree is like a subgraph of an undirected connected graph that contains all the graph's vertices with fewest number of edges feasible. And so here the important thing to note is that it is always a acyclic tree. The spanning tree is an acyclic tree always. And the another thing to note is that the number of edges in a spanning tree is equal to the vertices minus 1. Uh, Similarly, what will be the minimum spanning tree? So if the spanning tree contains weights, then the minimum spanning tree will be a tree that has the least number of weights when we count all the edges, all the weights of the edges. So a minimum spanning tree is a spanning tree in which the total weight of the edges is kept as low as possible. Next, so here is an example. For example, if there is a graph with weights, and what will be the spanning tree? If you want to make spanning tree, there can be multiple spanning tree. For example, we have to make it an acyclic graph. So we remove all the edges that are making it a loop. For example, this one and this two. So and also we have to keep in mind that the number of edges are one less than the number of vertices. So here you can, as you can see, there are the number of vertices is 5 and the number of edges is 4. Similarly, what will the minimum spanning tree? So the minimum spanning tree should contain all the vertices and the weight should be the least. So there can be multiple spanning trees, but there can be only one minimum spanning tree. So here if you can count the weight, there is 2 plus 1 plus 1 plus 3. So that was, 7 was the total. So that was the minimum spanning tree. Okay, now Kruskal's algorithm. What is Kruskal's algorithm? So Kruskal's algorithm is a greedy algorithm that we use to find the minimum spanning tree. Okay, so what is a greedy algorithm then? So a greedy algorithm is the one that selects the best solution for a specific period of time, regardless of whether the response is globally necessary solution or not. So the algorithm will keep picking the best solution, required solution, without considering whether it is the best, whether it is that whether it has any consequences or not. Okay, next, the working implementation of Kruskal's algorithm. So there are certain steps while you are following an algorithm. Similarly, for Kruskal's algorithm, first you have to sort all the edges in increasing order of their weights. So if there is a tree, then we remove all the edges and then we sort them in the increasing order of their weights. Then we pick the edge with the smallest weight in the second step, and then we place it in the graph. Okay, then we while when then we pick the next least weight edge, and we check whether it is forming a loop or not, and we keep checking whether it is forming a loop or not to avoid forming loops, because if there is a loop, then it is not a spanning tree. So then if it doesn't form a cycle, then we include the edge in the minimum spanning tree, otherwise we discard it. Like this we keep taking the edges according to their weights in the increasing order, and then we keep placing it and we check whether it is a cycle, it is forming a cycle or not. We repeat the step 2 until we include all the edges and we form a minimum spanning tree, and we avoid the formation of loops or cycles. Okay, let's see an example. So this is a graph which has weights. It is a graph which has weights, and we'll apply Kruskal's algorithm to find the minimum spanning tree. Okay, so here if we, without seeing the steps, what we can do is that there are certain weights for the edges, and first we can remove all the edges and then we sort them in increasing order. So the least weight, if you can see here, is this one, 10. So first will come 10, and then what is the next least weight, that is 12, then 14. So we can sort them in that way, and then we pick 10, we place 10 here only, then we pick the next one, 12, and then we 12, and we observe whether it is forming a cycle or not. So it is so far away, it is not forming a cycle. So we keep placing the edges according to the weights, and we avoid making cycles or loops. So here in first step we have removed all the edges, and in the second step we have put the 10, which is the least weight. In the next step we put 12, and it is not forming a cycle, and then we put 14, it is also not forming a cycle. So we keep putting the edges according to the weights, and we unless and until they are avoiding making cycles or loops. Here we have put weights according to their edges, according to their weights, and we have not made a cycle. Next step, so it is completed, all everything is completed. So first we have 10, then 12, then 14, then 16. It was not making a cycle. That was the minimum scientific. Now we observe the time complexity. What is time complexity of the Kruskal's algorithm? So the time complexity will be O E log E or O E log V. Okay, then sorting of the edges takes O E log E time. After sorting, we iterate through all edges and apply the find union algorithm. Find and union operations can take at most O log V times. So overall complexity is O E log E and E log V time. The value of E can be at most O V2. So O log V is O log E the same. Therefore, the overall complexity is O E log E or O E log V. So what are the real life applications of MST? So some of the applications are building or connecting roads among cities or villages at minimum cost. So you can see how it is comparable to the minimum spanning tree, how we can reduce the cost by forming the applying Kuskal's algorithm by using minimum spanning tree concept. Network services providers can find the minimum cost to provide services to every user. So this is very important because it reduces the cost, and it is a very important application. Cluster analysis of data sets, protocols to avoid network cycles. So these are some of the real world example applications of MST. So then we have the real world application of Kruskal's algorithm. So it is used to lay out electrical wiring, LAN connections, Google Map, mobile network, salesman, GPS. So here we can see that you have to think about the greedy algorithm. Since Kruskal's algorithm is a greedy algorithm, it gives you the best solution. In all these cases, if you have the best solution, only that will be the real life that will be very important for the real life application. That's why we have things like GPS and landline cable. You need the best solution in these cases. Okay, so that was it. That was all about minimum spanning tree and the Kruskal's algorithm. Thank you very much. My name is Divyam Singh, and I hope you enjoyed the video.